Section 5.2 exercises. Problem 1. Find the value of each of the 6 trigonometric functions of angle theta in the figure below. In order to do this, we need to find all 3 lengths of the side of the triangle, and we do not have the hypotenuse length here, c. So we will use the Pythagorean theorem. The adjacent side squared, 4 squared, plus the opposite length squared, 3 squared, is equal to the hypotenuse squared. So 4 squared is 16, and 3 squared is 9. 16 and 9 make 25, and the square root of 25 is the length of the hypotenuse, or 5 is the length of the hypotenuse. This is a standard 3, 4, 5 right triangle. And now we can get the values of the trig functions. The sine of the given angle is defined to be, look through this way, is the given angle. The opposite length, so 3, divided by the hypotenuse length, 5. The cosine of the angle is defined to be the adjacent length, here that's 4, divided by the hypotenuse, which is 5. And the tangent is defined to be the opposite length here, which is 3, divided by the adjacent length, 4. Once you have those 3, you get the other ones for free, because the cosecant of the angle is the reciprocal of the sine, so flip 3/5 to give you 5/3. And then the secant of the angle is the reciprocal of the cosine, so that's 5/4. And the cotangent is the reciprocal of the tangent, so that's 4/3. Or you could use your right triangle definitions of cosecant to be the hypotenuse divided by the opposite, and so on for the remaining 3 trig functions. Here I use the reciprocal identities. Problem 2. Same question as problem 1, but notice now we have the length of the hypotenuse, we have the length, angle is here, we have the length opposite, but we do not have the length adjacent. So still we go through the Pythagorean theorem. So the adjacent side squared plus the opposite length squared is equal to the hypotenuse square. So b squared plus 1 equals 25. So b squared is 25, subtract 1, 24. And so b is the square root of 24, or factoring 24 to be 4 times 6. We can then write that b is 2 root 6. So this is the length of our adjacent side. Now we can write down the values of the trig functions. The sine of the angle is the opposite length 1 divided by the hypotenuse 5. Cosine of the angle is the adjacent length. That's what we just found here to be 2 root 6. Over the hypotenuse length, 5. The tangent of the angle is the opposite length, 1, divided by the adjacent, 2 root 6. Here we'll have to simplify this fraction on the bottom by rationalizing and multiplying by 1, square root 6 divided by the square root of 6. That'll give us root 6 in the top, and it'll give us 2 root 36, which is 2 times 6 in the bottom. And so our final simplified value for tangent theta will be root 6 divided by 2 times 6, 12. And since we have these 3 trig functions, we can get the other ones by taking reciprocals. The cosecant of the angle is the reciprocal of the sine, so that would be 5 over 1, or 5. Then the secant of the angle is the reciprocal of the cosine, so that will be 5 divided by 2 root 6. As we multiply by root 6 divided by root 6, we'll write 5 root 6 over 2 times 6, or 12. So we'll rationalize that in the same way we did our tangent function down here in the left corner. And then our cotangent is the reciprocal of the tangent. Now notice, if you flip this simplified result for the tangent, you'll have to rationalize the fraction. So instead, flip this one, reciprocate this one, and it'll give you simply 2 root 6, no rationalization to be done. And all that is for problem number 2. Let's go on to problem number 3. Use the right triangle to find the cosecant of 45 degrees. Okay. Well, we have choices here. We can use our definition for the cosecant of the angle. Cosecant of 45 degrees. That is defined to be the hypotenuse length r divided by the opposite length y. So looking at it that way would give us root 2 divided by 1. Or we could look at it as cosecant of angle is 1 divided by the sine, since the cosecant and the sine are reciprocals. That would then force us to find the sine of 45. The sine of 45 is the opposite divided by the hypotenuse. And when you reciprocate 1 divided by root 2, you get root 2 as above. So both modes of thinking are correct, and here we show you both. Problem 4. Use the given triangle to find the tangent of 60 degrees. Okay, tangent of 60 degrees. First, make sure you're looking through the proper angle. 60 degrees is the given angle, so we want to view it this way. Put your eye there and look through the triangle. Tangent is the opposite length divided by the adjacent length. So we take that opposite length, root 3, divided by the adjacent length, which is 1. So the tangent of 60 degrees we can simply write as square root 3. That's all we need to do for problem number 4. So we'll go on to problem number 5. Given the value of sine theta to be 2/3 and the value for cosine theta to be root 5 divided by 3, find the tangent of theta using a quotient identity. Okay, so what it means by quotient identity is that tangent of the angle is defined to be the sine of the angle divided by the cosine of the angle. And since we're given the value of each, we'll put that in. We'll create a messy fraction, but we'll simplify it. The sine is 2/3 as given, and the cosine is root 5 divided by 3 as given. To simplify that fraction then, we take the numerator 2/3 and we multiply by the reciprocal of the denominator, 3 divided by root 5. Here we can divide out our 3's and give us 2 over root 5. Now that should probably be rationalized, so we'll write tangent theta 2 over root 5 times the square root of 5 divided by the square root of 5. And so tangent theta will be 2 square root of 5. And in the denominator, root 5 times square root of 5 is square root of 25, or simplified as 5. And there's our value for tangent theta using the quotient identity. Problem 6. We're given the value of sine theta to be 1/2. We know that theta is an acute angle. That means an angle less than 90 degrees. Find the value of cosine theta using the trigonometric identity, where the identity we wish to use is the Pythagorean identity right here. So we'll directly substitute very carefully. First, note that the way we write this, sine squared theta plus cosine squared theta equals 1, is best written as sine of the angle all squared plus cosine of the angle all squared is equal to 1. We write it this way, but it means this, and it helps a little bit to substitute the values in. Now sine theta given is 1/2, so we have 1/2 all squared plus the cosine of the angle squared is equal to 1. And we just have to solve this equation for the cosine. So 1/2 squared is 1/4 plus cosine of the angle squared is 1. Subtracting 1/4 from both sides, cosine of theta squared equals 1 minus 1/4. So that's 4/4 minus 1/4 is 3/4. So now taking the square root, cosine of theta is plus or minus the square root of 3/4, which is the square root of the top, divided by the square root of the bottom. Now, which answer do we take, the positive or the negative? Since the angle given is an acute angle less than 90 degrees, that means we are in quadrant 1, and the values of all the 6 trig functions are always positive there. So we choose the positive answer of root 3/2. Problem 7. Find a cofunction with the same value as sine 46 degrees. Okay. Cofunction. The sine and the cosine are cofunctions. If they are cofunctions, then it means that 1, the sine of the angle, is equal to the cofunction, the cosine of 90 degrees minus the angle. Cofunctions differ by 90 degrees. So we have the sine of 46 degrees, and that'll be equal to its cofunction, cosine of 90 minus 46 degrees. So this means that the sine of 46 degrees will be the exact same value as the cosine of 44 degrees. Or we could say that the cosine of 46 is equal to the sine of 44. Problem number 8. Find a cofunction with the same value as cotangent pi over 12. Okay. Cotangent pi over 12, and the cofunction is the tangent. So tangent and cotangent. So if we have tangent theta, that would be equal to its cotangent of 90, or pi over 2, minus the given angle, pi over 12. The tangent and the cotangent differ by 90 degrees. 90 minus the given angle, in radians, 90 is pi over 2. So now we'll do the arithmetic. We're given, I got this backwards, aren't we? We got this backwards, so let's try this again. We have the cotangent of pi over 12, and that'll be equal to the tangent of 90, pi over 2, minus the given angle, pi over 12. So our cotangent of pi over 12 is equal to the tangent. We need a common denominator here, which would be 12, so we'll write 6 pi over 12 minus 1 pi over 12. And we can now write our conclusion. Cotangent of pi over 12 is equal to the tangent of 5 pi over 12. Or, as I started to write before and crossed out, the tangent of pi over 12 would be equal to the cotangent of 5 pi over 12. So function and its cofunction always differ by 90, or pi over 2. And that concludes the section 5.2 exercises.